Okay, I want to give you one more piece of information that is very useful when you deal with DNA, and that's FASTA files. I'm aware I'm packing a lot into these lectures, but we only have got 5 lectures and then a lot of time to practice. So don't worry if this is overwhelming now. I've given you a lot of practice material, and we go through this in the labs. We have the whole term to come to terms with this, but at the moment, I'd rather try and move fast through this in the lecture so we can actually start getting into programs that are interesting and data analysis that is exciting. Right, FASTA files. This is the standard way we store DNA sequence information, and you will, when you download data from NCBI, from Ensemble or UniProt, for example, they will always come in this format. And the format is very simple. It's a text file where you start with this forward sign here, and then you have usually the ID and then some more information, name, species, and things like that. The problem is there is no real standard. So I think the ID in the beginning, straight after the initial mark here, is standard. So you can more or less be sure that that will be an ID. But then what comes after is quite varied. So it doesn't have a defined structure. So you can't really write kind of a robust code that will extract this information into different and bring it into different categories. But this initial header line is standard, and then afterwards all the other lines will be sequence. So we will, in this section, we will learn how to read in FASTA files into Python, which is a very important skill when you deal with DNA and protein sequence data. So there are just, so we've covered the essentials of FASTA files, but now it's like, how do we deal with this in Python? And here is a relatively complex program. So I won't go through this bit by bit. I encourage you to read it and try to understand it. This is, again, a skill I want you to learn, is to not just be force-fed information, but to try and understand what's going on here, copy it over into a Colab cell, and then play with it and try and understand it. We've learned all the parts here except for this with open statement. This is what we're going to learn now. And then we're parsing the file. That means we're processing its structure and trying to find this line here and process that and get it into a dictionary with a ID key and with an info key, and then extract the sequence as a single string. This is what this program here is doing. So it starts with making an empty dictionary, and then some keys like the current gene ID and the current sequence, and then it gets to the file. So we say with open file name, and the file name needs to be the path of the file. So in your computer, it needs to not just be the name of the file, but all the names of the folders and from the source, from the root folder to that file. We don't need to do that in Colab, so I just say file name here. And then there is a little character here, and in case here R stands for reading, because we're not changing anything in the file, we're just reading it in. So this is relatively self-explanatory. And with open that as file, we start now processing that. We go through line by line. We get out all of the blank spaces and then look for the line that starts with the symbol for FASTA. And then we're processing this, and everything else will be processed as sequence. And then in the end, we end up with a dictionary that will give us the final sequence. I can't really do this interactively here because we need to read in the file, and that's slightly difficult in the browser. But we can have a look at this in the Colab notebook, and again go through this very, very simple. So I won't take the time now to explain this step by step, but this should be self-explanatory, and we'll go through this in the labs as well. Now I just want to say a few words about this with statement, because that's an important way of dealing with files generally in Python, both file in and file out functionality. So reading and writing files. Initially, the original way was just say file, and then you open it, and then you read it, and then you get the content by reading this particular variable file that you opened here. The problem is you need, in order to not just leave this hanging, you need to, in the end, have this statement file close. And for example, if this crashes, before we reach this file close, this can hang, and this can generate quite a lot of problem. Memory leaks, file locks, resource exhaustion, memory problems, things like that. So we don't really want to do that. So the way to do it now is using this context manager. So with open is a context manager, and it just simply means it's the same as this code here, but we don't need to say the close anymore. That will be handled automatically and gracefully, which means even if the file crashes, the reading reading action will still be closed, and there won't be anything left hanging. So that's all to it. But remember, this with open is something you will use when you're reading files into programs locally, and again, we have got good practice for that in the Colab notebook. And then if you want to write out the file, we do this again in the Colab notebook. You just put a W here, and then you can write the file as well. So you can do input and output. So practice the notebook, go through it, and we'll answer questions in the labs about this.